let's look at the proofs for topic 6. This is the intro to proofs one. The kind of proofs we're doing on this topic are mostly algebraic proofs. So we're going to look at the statements that are given, and we're going to come up with reasons why we can make each of those statements. If we look between step 1 and step 2, what we did here was we distributed twice. So our reason would be distributive property. Okay, if you look at your sheet that shows the different choices that you have, this would have been choice E, our first one. And then to go between 2 and 3, if we look at what happened to get from 2 to 3, what we did on this side was we subtracted 10x, and on the other side we subtracted 10x. When you subtract the same thing from both sides, you're doing the subtraction property. POE for property of equality. And the subtraction property of equality is choice B. Okay, looking between 3 and 4, if we look at this, what happened was we added 24 to both sides. So that becomes the addition property, because that's what we did to both sides. Properties of equality are what you do to one side, you do to the other. And this was choice A. Okay, to get from 10x to x, we divided both sides by 10, which would be the division property. And the division property is choice D. Okay. Our last one is we changed directions. What was on the left became what's on the right. And this is the symmetric property. This is not the reflexive property. That is different. That's when we say x equals x. But when we change sides, we have the symmetric property. And if we look at our descriptions, that was reason H. Okay, let's look at the second proof. Okay, problem number 2. We are again starting with some distribution here. So our first step is that we distribute it. Distribution or distributive property. Okay, that is E. You notice we have 2 things that were given. So that was 1. We also are given y equals 4. We're going to use that later on, or in the next step. Now if we look between 2 and 3, the only thing different is that y changed into 4. And the reason we're able to do that is we were told what y equals. So wherever we have a y, we can put in a 4. That is what we call substitution. And on your list, substitution is F. So we didn't write very well there. F. Okay, going then between 3 and 4, if we look at what's different, what we did was we multiplied together 2 times 4 to get 8. Okay? Not really a property, but what we did here was we simplified where we did the math. On our sheet, simplify is a y, so we're going to put that there. Our next step is similar. What we did was we added together 8 and 4 to get 12. So again, all we did was simplify. And that's choice Y. Okay. To get from step 5 to step 6, what we did was we added 10 to both sides. That's how we got 2x is 22. So when we add to both sides, that would be the addition property. Addition property is choice A. When we get from 2x to x, what we did was we divided both sides by 2 there, which would be the division property. And the division property is choice D. Okay. We're going to flip the page over and look at proofs 3 and 4. Okay, the third one, we have a geometric proof now. So we're going to look at what we're given here. We're given that ADE equals BDC. So I am going to mark these on my table here. ADE would be that angle right there. Contains 2 of them. And then ADE equals BDC. So, our angle's right there. And what we're trying to prove is that ADC equals BDE. The 2 side angles equal each other. So we're going to go through this process with the statements to get there. The first part we're given is that those 2 angles equal each other. Then next, we move from step 1 where the angles are congruent to step 2 where the measures of the angles are the same. When we switch signs like that from congruent to equals, we are talking about the definition of congruent. The definition of congruence is P on our page. Okay. If we go to the next one, we want to look at what lets us say that ADE, the measure of ADE, is ADB plus BDE. So this whole first line is equal to the 2 smaller ones together. What lets us add 2 angles and get the bigger angle is angle addition. Okay, and that is O on our sheet. Okay. We're next going to add ADB and ADC together, and that will total BDC. That's again angle addition. We're adding 2 smaller angles together to get how much a big angle measures. So we have angle addition again. Number 5 is possibly a little bit confusing. So let me see where we're coming from here. We're starting with ADB plus BDE. ADB and BDE, and that is coming from line 3, ADB and BDE. Okay, and we're making that equal to ADB and ADC, which is coming from here. So the kind of confusing part is where it's coming from, or what we have underlined in red is coming from what the measure of BDC is, and we're finding that out here. Okay, and the part that we've highlighted in green is coming from ADB plus BDE, which is ADE. You notice that that's the other part of statement 2. So if we go ahead and take statement 2 and substitute into it what we have for 3 and 4, we will end up with statement 5. That is why this step is substitution. Which is F. Okay, so in other words, we're taking step 2 and we're turning those boxes into the underlines based on what the boxes equal on the next lines. Now if we look at the end between 5 and 6, we have 2 angles equaling 2 angles, and we're ending up with 1 angle equals 1 angle. So what's really happening here, we're also switching them around, but we're being left with ADC, And to get that way, we're subtracting the measure of angle ADB. And on the other side, we're left with BDE. To get there, we're subtracting the measure of angle ADB. So we are subtracting the same thing from both sides, which is the subtraction property. The subtraction property is B. If you wanted to become quite technical, we also switch the sides. So we did also use the symmetric property. Let's look at number 4. We're given some information here that ACD equals 5x plus 20. So I have ACD here, and I'm going to label it 5x plus 20. And I'm also told that BCE, should be this angle here, equals 3x plus 40. Okay? My goal is to prove that x equals 10. So let's see the steps that I'm given to prove it. I start with the two things that I'm given, right? And now I'm going to say that angle ACD is congruent to angle BCE. I mark those on the page, and we can say that because they are vertical. Or you can call it the vertical angle theorem. Vertical angles are choice M on your sheet. Okay. If we're going from the angles being congruent to the measures being congruent and only changing the sign, we are using the definition of congruence. The definition of congruence is P on your page. So now we have to figure out what lets us go from saying the measure of ACD and calling that 5x plus 20. Well, that's back from where we started. ACD was 5x plus 20, and we're turning ACD into 5x plus 20. We're going to do the same thing with the other angle. We're comparing it to BCE. And up here we have BCE equals 3x plus 40. So we are substituting into our equation with what we know they equal for the substitution property. Which is choice F. Okay, now we're looking at what happened between 4 and 5, what went away and what stayed the same. So the 5x stayed the same, but we got rid of 20. So I think we subtracted 20 from this side, and 40 became 20, so we subtracted 20 from that side. When you subtract the same thing from both sides, you're talking about the subtraction property. We're dealing with an equal sign here, so it's the subtraction property of equality, and that is choice B. Okay? Then to get from 5x to 2x, what really happened was we subtracted 3x from both sides. So if we subtract the same thing from both sides, we're using subtraction again. And it stays choice B. To get from 2x to x, what we did was we divided both sides by 2, and that is the division property. The division property is choice D.